Hello, I'd like to welcome you to the DConf Online 2022 workshop. Something that I talked about in my talk just before the workshop, and if this is the first video that you are watching in this series, I'd recommend you go back and watch the first video, which is more of a general overview and discussion about what it is we're going to do here in this workshop. But for me, I thought it'd be really interesting to introduce D in a way that people who might be new to coding, let's say you only know Python, let's say you've only been coding for a little bit, could learn something interesting about a brand new language, maybe their first compiled language, and walk away with a real, tangible, complex, and interesting and explainable piece of software. And something that have always been interested in is what I call programs that create programs, right? This kind of meta idea, right? Programming can solve lots of problems for us, but what if the problem that we're looking to solve is actually the business of writing programs, right? And there's many tools that we can use for that. There are text editors, IDEs, but there are also compilers and assemblers. And I've also been real interested in retro computing for a long time. I grew up with Z80s and 6502s, and so I thought it would be really nice for us to sit down together and kind of work on and produce a real working Intel 8080 assembler, right? Because if our assembler works for the 8080, it will also work with the Zilog Z80, and you can still actually buy those Zilog Z80s brand new from the factory if you so want to. All right, but let's sit down, let's think about it, let's talk about it, and let's get ourselves coding. So I have a couple of screens up here. I'll kind of have them up throughout the workshop. On my left here, I have my terminal, and just to kind of say hello and show you kind of what platform I'm on. One of the nice things about D is that it's very, very cross-platform. So I'm on OpenBSD. You can be on anything, Windows, Mac, Linux, another BSD. This code here will work on any platform. And on my right here, I have up a Firefox window, and whatever interesting thing that we're working on at the moment, I will have up here so that we can talk about it as well. So I also have in here just a quick makefile and general assembly file. Because ultimately what I want to be able to do is I want to be able to run this code. And it turns out that I do in fact have an 8080 emulator called TNYLPO, but if you can see here, if I try to just feed that assembly file into that assembler, we get a complaint that the command file name must end in .com. That makes sense because it needs to actually be an executable file, and this assembly file is not. So we're going to do the work together to convert this assembly file into the actual executable file needed to actually see the hello DConf online 22 message printed to the screen. All right, and I also have a quick make file just so I can just run make real quick and it will process. We don't actually have a complete program here, so at the moment it complains to us, but we will fix that in due time. One other thing I'm going to do real quick is just set my vimrc to kind of what I like for D programming. All right, so let's go back to our file. And the first thing that we always need to do in D, like we would in C or C++, is to come up with a main function. So I have to say all good things start with a single function. All right, and in D, you can either have things return void, as in not give you a return value, or you can have things give you a return value. I like for assemblers to have my assemblers give a return value at the end, because we could, in theory, take this assembler and make it part of a larger kind of pipeline with a compiler, possibly a linker, and that way we can detect in that pipeline whether or not our assembles were even successful. Because if they're not, there's really no reason to move on. Another interesting thing in D that you might be used to in C and C++, but is handled a little bit differently in D, is that D only takes one argument for its main function. In C and C++, they take two. In D, they just take one, which is an array of strings. So let's ask ourselves some questions. What does our assembler actually need to be able to do before it can start assembling? Well, the first thing that makes sense for me for it to be able to do is check to see how many input files we give it. And I want to make sure that the user only ever provides one input file. Now you could, right, as your own kind of improvement and enhancement on this assembler, find ways to make it process more than one input file at a time. But for us, I think one input file is going to be more than enough. So we can actually say, hey, program, args, being an array of strings, will have a length. And that length is equal to the number of actual arguments, the number of actual strings in this array. And so we can say, if the length is not equal to 2, then we'll just error out with a nice message showing us how to actually use the program. And so that's going to require us to come up with a new function called usage, and we'll say print this if we didn't provide a valid input file, then we quit the assembler. And we can say int usage, and usage doesn't need to take any arguments, so we can simply leave the arguments empty. And we can say we want to write a line, and we want to actually tell the user how to use the program. So the way you use the program is you say A80, which is going to be the name of our program, and then we say file.asm. And then we can say return 1 or something like that. WriteLine, for those of you who have used, let's say, C or C++, is pretty analogous to printf, but it is going to require us to import standard.standard.io. Right? And import is the way that we bring in functionality from either Phobos, which is the D standard library, or some other libraries that we might have available. I'm just going to be using Phobos for this particular program, but if you had other libraries, you can also import them with the import statement. Another really interesting thing about D is that there are lots of different ways to express yourself. D is a highly expressive language. And one of the things you can do with WriteLine is you can specify where you want your output to go. So if you don't put anything, it automatically sends your output to standard out. But since this is an error and traditionally you want to send your error messages to standard error, we can say standard error.WriteLine, and that'll say, hey, do your WriteLine call, but send the actual output to standard error. And now we can detect if the user has put in the correct number of arguments. And if they have not, then we can show them what to do instead. And then that user can fix their invocation the next time. Next thing we're going to want to do is create a new input file object. And we're going to declare this at the moment, but then we'll kind of come back to it in the next video. I'm going to try to make all these videos relatively short so that you can kind of follow along at will, and it's not going to overwhelm you any particular video. So we're going to make an object called input, capital I input. And for now, we're just going to say new input, and we're going to say args1. So this will, when we write the code, create a new input object. It's going to give that new input object an argument, which will be whatever the file we put in was. And we'll see that when we create these input objects, part of what we will do is we will read in the source file that we gave on the command line, and we will break it up into individual lines and store all that in one big object, and then that object can just hold all of our source code for us. The next problem we're going to need to solve is we're going to need to come up with some name for the output file. And it might be really neat if we could make the output file have the same name as the input file, but with a .com ending. And so there's this really handy function here called find split that you get for free in the D library. But it does require us, we can see here, to import standard algorithm. So I'm going to go ahead and do that as well. I'm going to say import standard.algorithm. And the command, or the function is called find split. And what find split is going to do, it's going to read in a string, and it's going to search for whatever it is that we have asked for as the argument to find split. And then it's going to return to us 3 different strings. Hopefully, if we put in something that actually has the string that we're looking for, it will return to us the string prior to the thing that we've looked for, the thing that we've looked for, and then whatever is left in the string afterwards. And another interesting thing about D is that you can set auto as your type for your variables, and D will automatically figure out what the correct thing to use for that variable is. I think you actually need it for find split because the find split's interesting. It returns an array of 3 strings. So we can search for that .asm ending. And so if we did in fact put in a file that ends in .asm, we should get back 3 strings. One string should be everything leading up to the .asm. The second string should be .asm itself. And then interestingly, the third string should just be empty because there shouldn't be anything after the .asm. And we can actually search for that. So the 3 strings we get back will be split index 0, split index 1, and split index 2. So we can say if split index 1 is not equal to .asm, or split at index 2 is not empty, there actually is just an empty method that you can call on strings to see whether or not they have anything inside of them. If either of those things are true, then we probably didn't put in a file.asm formatted file name. So once again, we can just say return usage, right? Teach the user how to actually use the assembler correctly. All right, and then we will need to create a new object, or output object. And again, we're going to cover our objects in the next video. So for now, we'll just say output output. So we'll have an input object and an output object, and we'll just say new output. And our output objects will have a file property, which will be the file name. And the file name then must be split 0 concatenated with the .com extension. Again, split 0 will be everything before the .asm in our file.asm input file. The tilde character in D is your string concatenation, so I can just say split and then .com. And then lastly, we need to actually do the work. And so to do the work, we will put everything into a try catch block. And then inside the try block, we will say assemble, which will be kind of our main processing function. And that'll take our input object and our output object. And that's really all we need. However, if something goes wrong along the way, we can throw an exception, and that exception will be caught here. And we can use the same trick. We can say standard error dot writeline, and then we can give an error message. And that error message for us will be the name of our program, A80, and we will concatenate that with the line that we're currently on in our input file. So our input object will have a method or property called line, and that will just return whatever line number we're on. And then we'll actually print out the message itself. So in the exception object, there is a property called MSG, which will be the actual message. And then we'll say return 1. On the other hand, if everything works, then we can just say return 0. And that's really all we need to kind of control our assembler. One other thing that we will need is we'll need standard dot conversion for this 2 here. So this 2 is also really powerful. We can give it something of any type. In this case, line is going to be some sort of integer, probably an unsigned integer. And we can just say convert it to a string. And then we're going to concatenate all the different string pieces. Right, and that is really it. So we're going to save our work. We will set up a Git repo so that we can save our work and make sure that we don't lose anything. We'll say git commit, first we'll say git add, then we'll say git commit, and we will say begin work, wrote a main function. And that's all for part one. So join me again for part two as we continue on our journey to write ourselves a easily understandable and followable Z80 Intel 8080 assembler.